Welcome to the lecture series. In this series, we are going to discuss on the supervised and unsupervised learning, and here we are going to discuss on with an application where the anomaly detection using the robotics for the health monitoring. So in the health monitoring, we need this help because for the earlier detection so that we can avoid the patient's critical conditions. So here we focus on the early detection and next predictive maintenance and sensor data analysis, and we use the machine learning algorithms for the continuous monitor, and we focus on the safety enhancement also. And coming from the starting stage, first we need to know the user needs. So we have to understand the operator needs and pain points, and we have to write it in the robot context, so to analyze the operation environments and conditions. And most probably we have to collect the data, and to here we have to identify the patient's critical conditions like indicators to monitor. And here from this data collection we go for the failure analysis, and from this failure analysis we study and correct it in the future. We have this impact on this future analysis. And next is a human robot interaction. So here we considered the safety and usability of the factors. Coming to the defining stage is here we have to define like the challenge here is we have to autonomously analyze the patient's health which is varying in conditions. So first thing is we have to define the problem statements. We have to specify the robot health monitoring challenges, like what are the data requirements we need, and what are the performance matrices we need, and what is the threshold criteria, like we have to set it out, and we have to go for the system integrations also. So this part is the most difficult part, and in this part we have to concentrate more because the requirements will give the final output. So if we use in focusing on this requirement, we won't get the optimal output. Next is the idea. So we have to go in for the development stage, and here we approach the system using the machine learning methods like supervised or unsupervised or hybrid approaches. And here comes the sensor fusion technique. So we have to focus on the multimodal data interaction for this monitoring purpose, and it is a real-time processing because edge computing for the immediate anomaly. Next is deep learning architecture. So we focus on the CNNs, RNNs, and autoencoders for this pattern recognition. And next is statistical methods. So we focus on the control charts and thresholds based detections also. Coming to the prototype development, we focus on the model architecture, training datasets, hyperparameter tuning, and as model architecture, we go for the neural network structures for this anomaly detections, and in training datasets, it comes for the labeled normally and abnormally operational data. Hyperparameter tuning is nothing but the optimization of model performance for the specific robotic systems, and API development is build interfaces for the real-time data processing, and last comes for with the visualization tools. It creates the dashboards for anomaly monitoring and alerts. And next is the testing. That is, we have developed this architecture, we have integrated data sets, and we have the sensor fusion to monitor this. But we have to go for the testing, like we have to test the performance metrics like positions and ROC curves, etc. And controlled testing is also needed because in this lab environments we have different temperature during the different various conditions. So the different in this dynamic environment we have to go for this control testing also. Field validation, user feedback is very important if we go for the reinforcement learning methods, and iterative refinement, yes, it is important for this continuous improvement based on this test results. And here you can see the applications and case studies on this particular topic, like we can use it in manufacturing like predictive maintenance, quality control, and production line monitoring. And in the healthcare robotics, we can look into the surgical assistance, rehabilitation, and patient monitoring, etc. And in agriculture, it is used in the autonomous harvesting, crop monitoring, and precision farming. So these are very few applications I have gathered here. Apart from that, there are various applications also, like in automobiles. and in industrials, as I said, it's in the manufacturing. And in case study also you can take, and you can have an deep case study like for example Waymo, etc. And coming to the summary part, yes, we have used this for the earlier detection, and we use the machine learning models and fusion sensor fusion techniques, and it can be used in the industrial like manufacturing, healthcare, agriculture, etc. And most probably it uses the self-learning systems for the continuous adaptations, and for the real-time processing we use the edge computing. So in the next lecture series we will come about the most interesting topic. Thank you.